Welcome everyone. So we're looking at another installment in the set of videos where we're addressing hypothesis testing on correlation coefficient. So here again we're given a set of data for two performance on two subjects, X and Y, and we're asked to test at the 5% level this of significance whether there's any relationship between the two subjects. So how do we start this? We start by writing down the hypothesis. So they do not have to tell us. We know automatically that is going to be our default. So here we start off with H naught is rho is equal to 0. Rho, of course, is the population correlation coefficient. So we want to know if the true correlation coefficient is 0, or notice how they've worded it, whether there is any relationship. Any relationship, it could be a positive relationship or a negative relationship. So therefore, rho is not equal to 0 would be the appropriate alternative hypothesis, making it a two-tailed test. So once I've identified the nature of the tail of the test, what I would strongly encourage you to do is then to now sketch a graph. So we have rho equals 0, and then we're going to have critical values associated with the significance levels. That has now been split into half. 2.5% on that side, 2.5% on that side. All right. So what we would do is we would go to our table and do make sure that you have printed off a copy of your data sheet or your formula sheet for your maths exam. You must carefully review the contents of it so that you know where stuff is placed. So here I'm looking at critical values for correlation coefficient, and I'm looking at product moment coefficient. So I have the level, which is going to be 2.5% that I'm going to be interested in, or 0.025, and then I'm looking at n equal 1, 2, 3, 4, 5, 6, 7. So I'm looking for n equals 7. So when I do that, I'm going to get 0.7545. 0.7545. Since it's a two-tailed test, it's going to be both positive and negative 0.7545. So in absolute terms, in order for me to reject the null hypothesis, I must get a value that is greater than 0.7545. Okay, so from here, there is an implicit task or an additional task that has not been spelled out clearly, but we definitely need to perform. We need to calculate our correlation coefficient, and the correlation coefficient that we'll be calculating would be the sample correlation coefficient in order to test whether the claim about the population correlation coefficient is true. I'm going to use the Casio FX9850 GC Plus in order to do this. So I'm going to go to stats, and the routines here should be similar for the CG50. So I'm going to go to stats, then I'm going to clear the table if there's any value. So you want to make sure you clear any values in your tables. I'm going to be using list 1 and list 2. So I delete all right, and now I'm going to enter into list 1 the X values. It doesn't really matter because the correlation will be the same if you put the X values in list 2 and the Y values in list 1. But usually for me, I'm going to use list 1 as my X. So 14, 21, 4, 12, 20, 16, and 37. And then now I'm going to go to list 2, and I'm going to enter my Y values. 18, 6, 7, 9, 27, 25, and 28. Okay, and now I'm going to go to calc, and then reg, and then X. So calc, reg, and then X. and I should get so I should get R equal, and my R value will be 0.6097. Okay. Now your calculator will also provide you with the coefficients for the linear graph that you would be using to fit against the data. So if I wanted to, I know that my coefficient would be 0.58x plus 6.83. That would be the equation of the linear line that would fit these data if I wanted to. Okay, so let's look at the question. So here, where does 0.6097 fall? Notice it falls in between the critical values. Therefore, we're going to reject, we're going to reject the alternative hypothesis. We're going to accept the null hypothesis. All right, because, so since the sample value falls inside the acceptance region, we accept H naught. So our decision is accept H naught. All right, so how would we write our conclusion? We would say there is sufficient evidence at the 5% level of significance to support the claim that there is no correlation between, there's no statistically significant correlation between X and Y, between the performance in the two subjects. All right, so, and that would conclude this particular question, part A of that question. Now in part B, they ask, explain why a linear model between X and Y might not be reliable to predict Y when X equals 40. All right, so beyond the fact that the relationship between X and Y is not statistically significant, note also that X equals 40 is outside of the data range. So what that means is that if we went ahead and you applied X equals 40 to the linear equation, then we would be succumbing to the dangers of extrapolation. All right, so the data generating mechanism might not ring true beyond the observed range of data. All right. All right, so I hope that helps you to understand what's required for a question of this particular time. All right, stick around for some more videos.